Welcome to this training session for the use of the software SILDIS Module 10 for the prediction of the noise emissions from building and other constructions. For our case study, we will consider a building face with a length of 40 meters and a height of 12.5 meters, including an envelope displayed in gray and two openings displayed in blue. Opening number 1 is a baffle silencer with an area of 16.8 square meter. Opening number 2 is an industrial door with an area of 22.4 square meter. For our case study, we will also consider an external noise source referred to as A, which is an aerocondenser with an area of 9.6 square meters. The steps allowing to get this noise map will now be presented. Our building face is displayed in gray here. Our horizontal distances are counted along x-axis. Vertical distances, this means height in this case, are counted along y-axis, and distances to the partition are counted along z-axis. Here we can enter the length 40 meters and the height 12.5 meter. The reception point where the noise level will be computed can be freely selected at any location in front of the building face. For example, in the center of the face, XR would be 20 meters and YR would be 6.25 meters. For example, we can select a distance of 20 meters from the face. Now we can enter a sound pressure level inside the building at 1 or 2 meters from the partitions per octave band, and we can select a diffusivity term which is variable depending whether it comes to a reverberant acoustic field or a free acoustic field, with all possible variations between those two steps. For the envelope, the area is calculated by a subtraction of the openings area, and we can enter the sound reduction index. For opening number 1, which is a silencer, we can account the geometry by entering 4 distances reflecting the extremities of the surface, 2 horizontal distances and 2 vertical distances. We can enter the insertion loss of the silencer. We can also account the sound power level of any internal additional sound source like a fan, and we can also account a directivity term which is depending on the location of the specified reception point. For the opening number 2, which is a door, we can account its geometry by entering 4 distances reflecting the extremities of this surface, and we can enter a sound reduction index. For the external source A, which is an aerocondenser, we can account its geometry by entering 4 distances reflecting the extremity of this surface, 2 for horizontal axis, 2 for vertical axis, and we can enter a sound pressure level as well as an eventual directivity. The sound pressure level is calculated by the computer at the specified location per frequency band and also as an overall A-weighted value. What we've got here is the contribution of each noise source to this sound pressure level, envelope, openings 1 and 2, and also external noise source A. This sound pressure level we can contextualize. For example, we can account the sound pressure level of another noise source, for example, another building face. We can account an eventual amplification of the sound pressure level at receiver points due to sound reflection. And we can also account an eventual background noise level. This sound pressure level can be compared to a specified value, for example, NR curve. The software provides the sound power level of the phase and also the contribution of each noise source, envelope, openings 1 and 2, and external source A as well. All those results and also some intermediary results are available in the form of tables per frequency band. And finally, the software displays the noise map. These are the main features of the software SILDIS Module 10. Thank you very much for your attention.